Hello, my name is Palash Shah. I'm a freshman at the University of Virginia, and my submission to Tensorflow 2.2's hackathon is Libra, the first deep learning library that allows you to create and train neural networks in just one line. So Libra was developed to kind of address two main issues with machine learning frameworks that already exist. So first is easy integration. So recently there's been a drastic move towards creating platforms that are easy to use and on the cloud. And the issue with having these platforms in the cloud is that integrating them into pre-existing workflows that already have hundreds of API endpoints is very difficult because it's hard to take all of that local data and move it onto the cloud. And this is exactly where Libra comes in because everything is local and everything happens in one line. Next is increased abstraction. So just like Keras makes it easy to use TensorFlow's features, Libra makes it easy to use Keras's features. And with Libra, everything is hands off. So you don't have to know what a sequential model is. You don't have to know how to pre-process your data set. You don't have to know how a convolutional layer works. So the way that users are supposed to work with Libra is based off of queries. Now, first you create a client object, and generally a new client object is created every time you have a new data set. So you pass the client object a path to your set. It doesn't have to be pre-processed, it just has to have the information you want Libra to use. Next, on that object, you can call a bunch of different queries. So one of them is a single regression query, and this will create a feed-forward neural network for regression. You pass that query what you want to do in a simple English statement. So in this case, we want to predict median house value. What Libra will do is that it'll use a part of speech algorithm to identify the target. It'll pre-process that set. It'll dynamically instantiate your model and train. It'll perform some initial hyperparameter tuning, and then it'll generate all the information, including plots, and store it back into your client object that you created. And because of this, you can call a bunch of different queries on one dataset or one client object. After you've done this, you can perform more deep tuning like hyperparameters or the number of units or the number of layers or the optimizer that you're using by calling .tune on that object. So now I'm going to demo these features. As you can see, I've created my client object and called the single regression query on that client object. And now as soon as you run, you'll be able to see a hierarchical process logger that kind of documents everything that Libra is doing so you can identify what's happening when you're training your model. And now Libra uses a callback function and other metrics to identify when exactly your model starts to overfit. And that's when it stops. So here it has identified that your model begins to overfit at epoch number 6. And then finally, inside the client class, it has created a regression ANN key and has stored your losses, the model, the appropriate plots, and finally the target for that model. Forward, Libra makes it very easy for users to develop image classifiers. The first way to do this is by calling generate set fit CNN and passing it labels that you want Libra to query Google Images and create a data set for. The second is by calling a standard convolutional NN query, which follows that standard query workflow that I mentioned previously. And lastly, you can call .tune on this convolutional neural network, which creates a hypermodel class, which establishes a tuning search space and then finds that best combination of hyperparameters. Other key components of Libra are auto dimensionality reduction, and Libra supports three dimensionality reduction techniques, and it tries all possible permutations and tries to find the one that maximizes accuracy. And then lastly, pipelining for contributors. I've created a separate module inside of Libra where I've separated all main components into standalone modules. And what this allows a user to do is that if, let's say, they've developed a better pre-processing technique, they can put it directly into that module and test to see if it works better than the current one. And what this does is that it creates a very extensible framework that's also easy to test, but then continually grow as more and more features are added. This is the sample output for the dimensionality reduction query. As you can see, this is the baseline accuracy, which represents the accuracy before reduction. These are each of the different permutations that were attempted and their respective accuracies, and this was the best one, which in our case was just random forest. For pipeline sampling, this is an example pipeline for the single regression query. Now let's say I developed my own preprocessor, which is my preprocessor, and I wanted to test it out. All I would have to do is replace this function inside this query to my preprocessor, and it would use my new developed function inside its pipeline. So those are just some of the features that Libra has to offer. If you would like a more in-depth analysis on what the library does, I've outlined the whole library under the table of contents in my GitHub. After TensorFlow 2.2's hackathon finishes, I plan to get as many people as possible to collaborate on this project and grow the library into something that people of all experiences can use on their projects. Thank you for listening.